Hi, ladies and gentle germs. We are going to be talking about graphing basic functions today, and we are really just worried about if I show you a picture of them, can you identify them? And that means put a name to them. So we're going to look at some typical different functions today, look at their graphs, put some names to them so that you can more easily identify them, and we're going to review types of symmetry. And when we say types of symmetry, we're talking about the graph is even or odd. All right. So this is the graph that you should all know and love. This is baby's first graph. This is the graph that you learn when you learn to graph, right? A linear graph. A linear graph is always going to be a perfect straight line. Any 2 points or every single point is what's called collinear. It's a straight line. The equation for that is going to be just y equals x, maybe plus a number. Maybe there will be a number in there, but it'll just have a plane x, and that's it. Okay, so that's linear. Sounds like line. It's a perfectly straight line. The next type of graph we can have is a quadratic. Sometimes these are called parabolas, or they're parabolic. These look like big U's. They flare out. They never get vertical, so you won't ever have one like this, where these are perfectly straight up and down and become parallel. Parabolas continue to flare out forever, so they keep getting wider and wider. This one is y equals x squared plus 2, but you should be able to just look at a big U shape and go, oh, that looks like a parabola. If I give you the equation, the way you can tell this thing will look like a parabola is because the biggest exponent on any of the x's is a 2. If we want, we can even flip our parabola upside down. This is still a parabola, even though it's not the U shape anymore, it's flipped. Still a parabola. That's okay. The way that you get them to flip over is by having that negative. You're going to say, Mr. Barton, this x isn't squared. But we have a squared here, and when you take your x plus 1 and FOIL it, or distribute it out so that you get the full polynomial, you'll end up with an x squared. All right, so hopefully you've seen those before. They're either called quadratics or parabolas. They're parabolic is the adjective. Okay. Here we have exponentials. Excuse me, I think I hiccuped a little bit there. Exponentials are super useful because a lot of things in nature follow an exponential trend. Things that follow exponential trends are things like population, bacteria, a lot of things like that. And then everyone in grad school who's watching this high school video is going to go, well, technically, population curves follow a logistical curve. Shut up. Okay. Exponentials are pretty easy to identify because one side of your exponential looks like it's getting really flat. It's getting near what is called an asymptote. And what that means is this is an invisible line. So maybe I should make it dashed so we can tell it's not like a real thing. It's an invisible line that our graph of the function is getting closer and closer and closer to. And then the other side will just diverge. It'll go either up forever or down forever. You can flip these over so that it approaches the asymptote on the right side instead of the left side. It's also possible to have exponentials that do this, where they're kind of flipped upside down, or you could have it reversed where it's going down towards negative infinity. Anything that levels out on one side and then curves up forever on the other side, that's going to be an exponential. Okay. Exponentials are made by putting your dependent variable or your input variable or your domain variable, whatever you want to call it, you put your x in the exponent. This base can be pretty much anything. 1 is pretty boring, so we kind of don't let you do that. And negative numbers get a little funky. So usually we just say this could be any number greater greater than 0, but not equal to 1. All right. Last graph that we're going to put a name to, I think. Let me double check. Nope, I lied. Second to last one we're going to put a name to is the absolute value graph. These are very similar to parabolas where they form U-shapes. However, the absolute value graph comes to a sharp point at its vertex. And its arms are made of perfectly straight linear. Hey, check that out. That's that graph you just learned right there. Perfectly straight linear arms instead of curved arms like parabolas. Like parabolas, you could make new graphs where your graph is flipped upside down. Unfortunately, you can't really make those sideways ones. We can force it if we're really into that sort of thing, but this isn't even a function, so most of the time we're not going to worry about it. This thing is someone else's problem, not ours. And you can tell that you're going to get an absolute value graph because of the absolute value in the equation. All right, and this is the actual last one. Let me check before I lie to you again. Yeah, see? Last one. This is a trig graph. We are going to go over trig functions way, way, way later. I think that's the last unit that we learn. But there are technically two. This one is y equals sine, pronounced like that, spelled like that. It's sine, not sin. It's not the thing that you get accused of doing in your bedroom with your boyfriend or your girlfriend. This is a math operation. Sine graphs look like waves that repeat forever. So if you're seeing a wave somewhere that's going on forever and ever and ever, looks like this, that's a sine graph. There is a second trig function that looks almost exactly like this that is called cosine. Don't say cos or cos. It's cosine. Just say the word. Sound intelligent like you learned what you're talking about. So if you see one of these wavy graphs, you are looking at a trig graph. Trig is short for trigonometry. Trigonometry. And again, you just have to be able to recognize this right now. You don't have to be able to do anything with this graph or solve any equations. You just have to go, oh, that wavy thing, that's a trig graph. All right. There are many, 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 many other types of graphs. I'm going to put in a new page here. I mentioned that grad student know-it-all namby-pamby one. There's things called logistical graphs. They kind of look like exponentials, but then another exponential happens and they level back out. You can get really weird graphs if you do different coordinate systems. You could get graphs that look like this. That one's pretty easy. This one is r equals theta. That's cool. That one's pretty fun. You can get a bunch of different graphs. You guys should Google the Mandelbrot set. Or actually, maybe not set. Maybe fractal. Fractal? Spelling is hard. I'm a math teacher. This graph is really, really pretty. I don't know. It's fun to look at. It makes my brain feel good. So you go look at that. My point is, this is not a complete list of graphs. There are so many weird-looking graphs in math. But these are the ones we kind of expect you to know. Linear, quadratic, exponential, absolute value, and trig. All right. Now, let's go ahead and go back over the two types of symmetry that we can see in graphs. And again, I don't want to lie to you. There are other types of symmetry besides just even and odd. But those are the ones that the state of Arizona decided were super important and you had to learn. So let's talk about even symmetry. A graph has even symmetry if it is mirrored across the y-axis. So if we look at a vertical line on the y-axis, this side of the graph looks exactly like that side, but flipped over. Okay. So if you can take your graph, let me move this word flipped. If you can take this whole graph, let's group that thing together, group, and then you flip it horizontally, flip left, right. It doesn't change. You can see the numbers are backwards now, but the graph looks exactly the same. So that means this thing has even symmetry. It's even on both sides, right? Same thing here. If we fold it right in the middle, this side will meet exactly with this side, so it's also even. The other type of symmetry that you need to know is odd symmetry. And a graph has odd symmetry if it has a rotational symmetry around the origin. And I'll explain that in a second. If you rotate the graph 180 degrees around the origin, the new graph should look exactly the same as the old one. So now, instead of taking it and folding it across something, we're not doing that. Whoops, excuse me, back up, undo. What we're doing instead is we are putting a point at the origin right there. Excuse me, hold on, I'm a professional. Let's stick these things together. And if we flip this and spin it around, so you want to picture you are kind of putting your finger there. How do you draw fingers? Let's see. Like your knuckles, right? I suppose you got like a thumb or something, right? That's your hand. Oh, God. Bless America. Anyway, okay. I'm a math teacher, not an art teacher. Go talk to someone else. If you flip this thing 180 degrees, it should look exactly the same, is the point. You do not need to have it be continuous. If we take this graph, flip it 180 degrees, it still looks exactly the same. It still has the same points. Oh, look, there's 1, 1 right there. There's -1, -1. If I flip this thing over, 1, 1, -1, -1, still the exact same graph. So odd symmetry just means that we can spin it around the origin and have the graph look the same. So there are your notes. If you need any help with that, let me know. Otherwise, enjoy your homework.